Hello students, in this session we will see around like 11 to 12 sums, fine. So those sums will be related to the dot product, okay. So we'll use this formula work done, that is equal to vector f dot vector d, okay. So we will do sums based on that also. Finally, we will see sums that are related to the kinetic energy and momentum conservation, right? So we'll do around like 11 sums in this session, got it? So we will need around like 6 to 7 sessions to complete all the PYQs in this particular chapter, okay? So you got around like 70 sums, therefore I think we'll get around like 6 sessions to complete this chapter, right? So let's jump into the first sum of this chapter. So let's do the solving. So the first sum is a particle moves so that its position vector is given by vector r, that will be equal to cosine omega t x cap plus sine omega t y cap, okay. So here it is pretty obvious. This is actually a circular motion, right? So this equation is something that we have seen already in the chapter of motion in a plane, right? So when you get this equation, it should be pretty obvious. This is something, an object that is moving in circular motion. So in this situation, it is obvious for x cap, which means for I cap, they have given like cosine component. Therefore, this rotation should be in anti-clockwise direction, right? So we have seen all these things clearly in the chapter of motion in a plane itself. So that part should be clear. Where omega is a constant, where omega is constant, fine. Which of the following is true? So what should be true? That's what I need to find it over here, right? So omega is constant actually means the angular velocity over here is constant, right? So let us read the options and let us find out which one will be true. Velocity is perpendicular to vector r. Okay, that is true, right? So this is actually a circular motion. Therefore, if this was like vector r for this particular circle, then obviously velocity will be perpendicular to this vector r. Therefore, velocity is perpendicular to vector r is actually correct, fine. And acceleration is directed towards the origin. Obviously, that should be my answer, because when you have uniform circular motion, obviously the acceleration will be directed towards the origin, right? So this sum should actually come in motion a plane chapter anyway. So I have put it in work, energy and power. You shouldn't have any confusion regarding that stuff, okay? So this sum is actually from the chapter of motion in a plane, okay? So let's see what are all rest three other options, fine. So velocity is perpendicular to vector r. So that is obviously correct, right? So velocity is perpendicular to vector r is correct, and acceleration is directed away from the origin. So the second part is wrong over here. So this option shouldn't be the answer. Velocity and acceleration both are perpendicular to vector r, okay? That is wrong, right? Fine. So one is actually perpendicular and the other one is directed towards this origin, okay. Velocity and acceleration both are parallel to vector r, so that too wouldn't be the answer, right? So option 1 is the answer over here, right? So as I've told you, right, so you'll get like super easy question from this particular chapter, right? So you should learn this chapter clearly, and this chapter is also foundation, and from this chapter we will build the rest all other chapter, right? So you should be thorough in this chapter, both in the concepts, same way in the sums, right? Okay, so you shouldn't have doubt in this sum. Let's move on to the next one. This sum is based on the mathematical understanding of the dot product that we have learned. Okay, let's see what the sum is. If vector A equals cosine omega t I cap plus sine omega t j cap, and vector B, that will be equal to cosine omega t by 2 I cap and then plus sine omega t by 2 j cap, or the functions of time. Okay, so they have given us like two vectors, fine. So obviously this vector is for the equation of circular motion, right? Okay, or function of time, then the value of t at which they are orthogonal to each other, right? So I have to find at what time t these two vectors will be perpendicular to each other, right? So that is what is meant by orthogonal, right? So when will, at what time these two vectors will become perpendicular to each other, that's what I need to find, right? So that's what is meant by orthogonal. Okay, so if that's the case, here it should be clear. These two vectors have to be perpendicular to each other. When two vectors are actually perpendicular to each other, if I do the dot product, so what will be the answer? So if it is like perpendicular to each other, then obviously that's going to be 0, right? So there should come a time when the dot product of vector A and vector B has to go to 0. So at that particular time, these two vectors will be perpendicular to each other, right? So that's the idea, right? I have told you, right? This sum is based on the mathematical understanding that we have developed over the dot product, okay? So from that, I'll have to solve this sum. Got it? So here you have got like vector A dot vector B. So these two vectors have to be perpendicular to each other. Therefore, it should be equal to 0, right? Now, if I just do the dot product of these two vectors, I'll end up getting the answer, right? So let me do it. You will have cosine A, which will be like omega t I cap plus sine omega t j cap. Okay, so that will be my first vector. Dot product of the vector B, which will be like cosine omega t by 2 I cap plus sine omega t by 2 j cap, right? That will be equal to 0, right? So next step is something I'll have to do with the dot product, right? So if I have to do the dot product, then I'll have to multiply the same component, fine? Perpendicular component will become 0. Therefore, I'll have to consider only the similar components. I'll have to multiply it with I, same way for the j, right? If I do the multiplication of similar components, I'll just end up having something like this, got it? So you will have cosine omega t, that will be the first one. Same way you will have like cosine omega t by 2. I just multiplied I, and then you will have like plus sine omega t, and then you will have sine omega t by 2. Got it? So that will be equal to 0. So that's the first equation that is needed. So here I'll have to use the trigonometric relation that I've already learned. Okay, so the trigonometric relation will be the fourth one. Fine. So from the theory, I have told you, right, you should have memorized all those 5 trigonometric relations that I've given you, right? If only you know the trigonometric relation by heart, you'll be able to do this one. So here you have got like cosine A cosine B plus sine A sine B. So this is the fourth one, which will give you like cosine A minus B. Okay, so you will have like cosine omega t minus omega t by 2. So the next one will be this one, cosine omega t my A minus B. Therefore, you'll have like omega t by 2, got it, which will be equal to 0. Omega t minus omega t by 2, fine. So here cosine theta, so this entire term is actually theta, right? So cosine theta equals 0. So for what theta, you'll end up getting 0. Obviously cosine 0 will be like 1, 0 degree. In the situation, it has to be like 90 degree. Cosine 90 degree will give you the answer to be 0. Fine, so you should remember that graph. So 90 degree over here is actually pi by 2. You'll have to substitute it in radian. Fine, even if you look at the options, they have given everything in terms of pi. By the way, radian is something that has understanding and logic behind it, got it, based on physics. But with the case of degree, that is something that's an extra concept that I actually found for our easy understanding, right? So I have already told that relation between degree and radian while doing the first chapter, which is like units and measurement. You should be clear, fine. Anyway, from the option, it will be pretty obvious. I'll have to substitute radian. Even if they have confused you, you should be clear. I'll have to do it in terms of radian. Then finally, after getting the answer in radian, I'll be able to change it to degree, right? That is possible. But initially, whatever we substitute inside the theta has to be in terms of radian, okay? So that's the idea that you need to know. So here, obviously, what will give you 0? Cosine pi by 2 will give you 0, right? So let me do it. So if cosine pi by 2 was equal to 0, so the next step will be, yeah, omega t minus omega t by 2 will be equal to pi by 2. Okay. Now what they're asking us to find is actually the time for which those two vectors will be perpendicular, right? So just factor out omega t. Okay, so if I do factor out those two stuff, you will have omega t minus, no, omega t, and then inside the bracket you'll have like 1 minus 1 half, that will be equal to pi by 2. And then what I need to find is t, therefore t will be equal to pi divided by, you'll have like 1 half over here, therefore that will go to the other side, so you will end up having pi by omega. Okay, so that will be my answer, right? So pi by omega will be my answer. So here pi by omega will be the option 1 in this situation, therefore option 1 is the answer over here, right? So you should be clear with this sum, right? To solve this sum, you should have good mathematical background understanding of the dot product. Same way, you should know the trigonometric relation that I've asked you to memorize. Okay, so if you just know that one, just do the solving straight away, you will end up getting the answer, right? You shouldn't have doubt in this sum. Let's move on to the next one. Next sum is also simple, easy one. Let me do the solving. If you have like, if a vector 2 I cap plus 3 j cap plus 8 k cap is perpendicular to the vector another one vector that they have given here is 4j cap minus 4I cap plus alpha k cap. Okay, so here they have given these two vectors are perpendicular. That's the condition that I need to take. Okay, then the value of alpha is, if these two things have to be perpendicular to each other, then what should be the value of alpha? That's what I need to find it over here, right? Let me do it. Then obviously vector A dot vector B has to be 0 because those two vectors have to be perpendicular, right? So you will have like 2I cap plus 3j cap plus 8k cap dot product with the next vector, it will be, which will be like 4j cap minus 4I cap plus alpha k cap, which has to be 0, which has to be equal to 0, right? Then the value of alpha is, so what will be the value of alpha? This is something that I need to find, right? So let me do the dot product. So same component, I'll have to multiply it, right? So if I do multiply that one, so 2, and then you have got like negative 4, right? They have just switched the places between j and I over here. So it will be like minus 8. Okay, for the next one, it will be like plus 12. And then for alpha, it will be plus 8 alpha, which should be equal to 0. Okay, so you have got like 4 on the left hand side, and then if it goes to the other side, it will become like negative 4. So that will be like minus 4. Therefore, alpha will be equal to minus 1 by 2. So the answer here is option 2, right? So the sum is also easy, simple sum, straightforward sum. You shouldn't have any doubt in it. Let's move on to the next one. This sum is kind of statement based sum. Let's see what the sum is. The vector sum of two forces, okay? So I'll have to do the summation of two forces is perpendicular to their vector differences. In that case, the forces are, okay? So I'll have to do like simple mathematical solving. From that solving, I'll have to find an inference and then I'll have to match it with these statements, okay? So here, how should the two vector actually be is summation of those two vectors and differences of those two vector has to be perpendicular to each other, right? So from the statement that they have given, let me generate an equation. Fine. First, let me write the summation of two vectors. That's going to be like vector sum of two vectors, right? So vector f1 plus vector f2. Okay. Now I have done the summation of these two vectors. It has to be perpendicular to the difference of those two vectors, right? Then obviously I'll have to do the dot product. So dot product with vector f1 negative of vector f2. Okay. That has to be equal to 0. Got it? So this is the equation that I'll be able to generate from the statement that they have given over there, right? Next, let me do the dot product for these two vectors, fine? So if I have to do the dot product, what I need to do is first I'll have to do the inner multiplication for these two terms, which is inside the brackets, okay? So if I do that one, first I'll end up getting like vector f1 dot vector f1, okay? So what will be the dot product of multiplication of two same vectors? So that's going to be something like this, right? Yeah, it should obviously be like f1 square. Anyway, if you have like vector f1 dot vector f1, what these two vectors are actually same and they are oriented in the same direction, therefore the angle between them is 0, right? So you will have like modulus of vector f, so you'll end up having vector a dot b, right? Therefore you'll have like modulus of vector a, that will be like vector f1 modulus of vector f1, and then you'll have like modulus of vector f1 and then cosine theta. So here it is like cosine 0 degree, therefore this one will be like 1. The answer for like vector f1 dot vector f1 for the same component, I'm just doing the dot product multiplication, which will give you the same answer. That's going to be like f1 square. That's it, right? It's a kind of normal multiplication with the case of similar vectors that is getting multiplied in terms of dot product, okay? So obviously here for the first step you will have f1 square, okay? Let me write it in terms of magnitude itself because you will, that's the answer that you are going to get anyway, right? So that one should be clear. For the next term you will have minus vector f1 dot vector f2, okay? And then for the next term you will have plus vector f2 dot vector f1, and then for the third term you will have like negative of f2 the whole square, which will be equal to 0, right? So if I just cancel it out, I'll end up getting the answer. That's it, finished. Okay, if I do the cancelling stuff between these two vectors, negative of vector f1 dot f2, and then this term is going to be like positive. So these two vectors, whatever it is, actually the dot product verifies the commutative law, which means even if you just switch places, you will end up getting the same, right? Vector a dot vector b is equal to vector b dot vector a. It doesn't matter which term is going to be first, whatever the case it is, you'll end up getting the same answer, right? Because the output answer is just going to be the multiplication of I component with I component, j with the j, and k with the k. Therefore it obeys the commutative law. Therefore obviously these two answer is going to be the same of magnitude. One term is positive and the other term is like the negative. One term is like negative and the other term is positive. Therefore these two terms will get cancelled out. Okay, so finally I'm just left with f1 square minus f2 square. If I'm just going to rearrange this one, you will have like f1 square that is equal to f2 square, and then if I ended up taking roots, you will have f1 which is equal to f2. So now let me match the result that I've got over here with the options that they've given in the question. Okay, so the first option is like or equal to each other, which means vector f1 is equal to vector f2, right? In this situation, I've just found f1 is equal to f2, which means those two magnitudes have to be same, right? So in the case of vector f1 equal to f2, direction is also same way magnitude is also same, right? If that was the case, if you just look into this step, okay, the first step, it is pretty obvious. If these two vectors are same, when I do the difference of these two vectors, obviously you'll end up getting 0 to be the answer, right? So it should be pretty obvious if they are equal to each other both in terms of vectors and then the magnitude. If that was the case, then obviously in the first step itself you'll end up getting 0 equals 0, right? So that shouldn't be the case. So obviously then option 1 shouldn't be my answer, right? So when you look into the second option, it is clear or equal to each other in terms of magnitude, right? So if that will be the case, then obviously vector f1 plus vector f2 will give you some result. Same way vector f1 minus f2 will not give you 0, that too will give you some other result. When you do the dot product, you will end up getting perpendicular component to each other. Then you'll end up getting that those two things are perpendicular to each other, right? Therefore the answer should be like or equal to each other in terms of magnitude. Even if you look at the final result that I've got over here, I just got the magnitude, right? Instant I do the dot product, you ended up getting the magnitude, right? So it is pretty obvious those two vectors have to be equal to each other in terms of magnitude. If those two vectors are just the same vector, then in that situation vector f1 minus vector f2 will in itself go to 0. Therefore in the first step itself we will end up getting 0 equals 0, right? So that shouldn't be the case. Only thing is summation of those two vectors, difference of those two vectors have to give the perpendicular component. Therefore you should have the value into it, right? Therefore first option is in the answer, option 2 is my answer, right? It should be clear. Then you have got like 3 and 4 option, which is like are not equal to each other in magnitude. That's not the case. Same way cannot be predicted is also not the option, right? Therefore option 2 is answer here. It should be clear. Let's move on to the next one. This sum will be from the concept of work. Okay, so I'll use the formula work, which is like vector f dot vector d, right? So here you've got like consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. Okay, so you're having a raindrop that is falling down from a height of 1 kilometer from the cloud. Got it? And the mass of that raindrop is equal to 1 gram. So that's what they've given over here. So that's the first statement. Then you have got it hits the ground with the speed of 50 meter per second. So when it reaches the ground surface, the velocity of that particular drop is going to be like 50 meter per second downwards. Take g constant with value of 10 meter per second square. Okay, so acceleration due to gravity is constant, that will be equal to 10 meter per second square. Fine. The work done by the gravitational force and the resistive force of air. Okay, so I need to find like two different work in the situation. One is the work done by the gravitational force and the other one will be the work done by the resistive force of air. Okay, so I'll explain you what is meant by resistive force of air. As if now in order to get the work done by the gravitational force, it should be clear that what was the work that was released in terms of kinetic energy. That's what they're asking us to find. If you do not have any air drag force in that situation, then what will be the work that was given by the gravity for that particular water droplet. That's what I need to find. Okay, so if that was the case for the first one, I'll do the second one after completing the first case. Okay, so the first case is simple and easy, straightforward one. So you're having a ground surface, and then water droplet is going to fall down to the ground surface from the height of 1 kilometer. Okay, so the height will be equal to 1 kilometer, which is like 10 power 3 meters. Okay, then I'll have to take I'll have to take the acceleration due to gravity to be like 10 meter per second square, and the mass of this water droplet was equal to 10 power minus 3 kg. Okay, I'm using the SI convention over here, right? What I need to find here is the work done by the gravitational force. Okay, so work done will be equal to, so here work done will be equal to vector F dot vector D, right? I'll have to do the dot product between the force and then the displacement. In this situation, let us find the direction of the force and then the displacement. Okay, so the gravitational force was downwards, right? So Fg was downwards. Same way, the displacement is also downwards. Okay, so these two components are actually in aligned and parallel to each other. Therefore, obviously, if I do the dot product between these two things, I'll end up getting the answer to be positive, right? So in this situation, the energy got released in the form of kinetic energy. Okay, in that, if that was the case, work done has to be positive, right? So that's the notion behind the work done, right? So when they are asking us to find the work done, I'll use this formula, vector F dot vector D. If the answer was like positive, then the energy got released. If the answer was like negative, then the energy got stored into that system, right? If it is if it is a conservative force, then obviously that will be transmitted to other form. In this situation, and when the case of in the case of the resistive force given by the air, that's not conservative, therefore it will get dissipated to the surrounding. Okay, so I'll do that one in the second case. As if now you should be clear with the first case. Okay, here if I do the dot product between vector F dot vector D, I'll have something like this. These two things are parallel to each other, therefore the answer is going to be positive. And then for the force, you will have like 10 for the acceleration, and then for the mass you will have like 10 power minus 3, right? Okay, so that will give you the force. Dot product, I have just removed the dot product. Only thing is the magnitude that I'm putting over here, because I know the answer to be will be in positive. Okay, and then D over here is actually 10 power 3. Okay, so 10 power minus 3 and 10 power plus 3 will get cancelled. Therefore work that was actually released by the water droplet because of the gravitational field will be equal to 10 joules. So the first answer has to be plus 10 joule. Okay, this one has to be clear. So that was the energy that got released. Got it? So the energy that got released will be equal to 10 joule. That much amount of energy has to be produced because of that water droplet due to the gravitational field. Okay, so first one has to be like plus 10 joule. Therefore the answer should actually be the option 3, right? Only if you just find out the first one, you'll end up getting the answer in the situation. So let me do it for the second case also. Okay, so for the second case, that will be a little bit tricky. Okay, so what they're asking us to find is how much energy got dissipated to the surrounding because of that air drag force. Fine, so to calculate that one, what I have to do is, what they've given over here is actually it reached the earth's surface with the speed of 50 meter per second. If there wasn't any air drag force, obviously it has to be greater than 50 meter per second. Okay, so if there wasn't any air drag force, in that situation, final velocity will be equal to root 2 gh, right? So kinematic equation, right? So in that case, you'll have like 2 into 10 power 3, so that will give you like 100 root 2, right? So 100 root 2 meter per second. So it should have reached the earth with the speed of 100 root 2 meter per second, but in this case it just has reached the earth with the speed of 50 meter per second. Then it is pretty obvious some part of the energy has lost to the surrounding. Okay, right? If it was like 10 joule, when it has reached the earth's surface, it should have like 100 root 2 meter per second, but that's not the case over here. It is less than that, which is equal to like 50 meter per second. So what I need to find here is actually the energy that got dissipated to the surrounding, right? So to get that energy that got dissipated to the surrounding, obviously what I need to do is I'll have to find the work done given by the air. Okay, so work done given by the air is actually the resistive force given by the air dot product with vector D. Okay, so in that situation, the resistive force given by the air will be opposite to that of the gravitational field. Okay, but I do not know what was the resistive force given by the air. This term isn't known. They haven't given any information to that of the resistive force given by the air. Obviously, these two things will be opposite to each other. F resistive force given by the air will be like plus j cap, displacement will be downwards, right? As these two things are opposite to each other, you will end up getting the negative sign. First, let us verify the sign over here. It is pretty clear. The sign is negative, which means these two things are anti-parallel to each other. If it was like conservative force, which means a kind of situation where you are pressing against a spring, in that case energy will get stored. Force of gravity was conservative, therefore it got released in the terms of kinetic energy. But in this situation, because of the air drag force, that particular energy will get dissipated to the surrounding in the form of heat and other stuff, okay, sound, things of that sort. But in this case it is not conservative, therefore I wouldn't be able to get back that stored energy. But it is pretty obvious those two forces are opposite to each other, therefore you should get a negative sign over here, right? So that part should be clear. That is why I've plugged in negative over here. That is why I've got like negative over here. Fine. So now what I need to find is just the magnitude. The magnitude has to be equal to 8.75. That is what I need to find. If it has fallen down without any energy loss, it should be like 10 joule, right? But in this case, the velocity was less, that was equal to like 50 meter per second. They have given us the velocity. So if I do the subtraction between the real, I mean the idealized situation, that's going to be like 10 minus of the energy that I possess right now in that water droplet, right? If I do the subtraction between those two terms, then I'll end up getting that energy that got lost to the surrounding, right? You should be clear, right? Let me do the difference. You'll understand much more clearly. So if I'll have to do the difference between, I'll have to do the difference, right? So work done by the resistive force of air will be equal to the 10 joule. That's what I'm expecting, but that's not the case. Some part of energy has lost, and the final energy with which it reached the ground was equal to minus half m. Mass of the water droplet was equal to 10 power minus 3, and then v square, which was like 50 meters per second. Okay, so these two difference will give you the amount of energy that got lost to the surrounding, right? You should be clear with that idea. So if I do subtract these two, I'll end up getting the answer. So that will be equal to, let me do this solving of the second term over here. So you'll have like half. Okay, so you've got like 10 power minus 3 and then 50 into 50. Therefore, you'll have 25. So that will be like 10 power minus 1. Yeah. So you will have 0.1 over here. Okay, so if I do the solving, so that will be like 0.05. Okay, so if it was like 0.05, 5 into 25 will give you like 125. So it will be like 1.25 over here, right? So 10 minus 1.25, right? Therefore, you will have 10 minus 1.25 will give you like 8.75. Okay, so 8.75 was the energy that got lost to the surrounding, right? From the equation that I've built over here, it should be clear. The answer will be like positive. This should be the energy if it was like idealized situation, but the energy that I got was like something less than that. If I do subtract these two stuff, I'll end up getting the energy that got lost to the surrounding. So that term has to be positive, because obviously this one is greater when compared to this entire term. Okay, therefore the answer was like positive. But you should know this, these two things are opposite to each other, therefore the work done over there, force and the displacement were opposite to each other, therefore I got the negative sign over here, right? So it is pretty obvious here, like 8.75 has to be the magnitude. So that has matched with the 8.75 that they've given in the question, right? So this sum should be clear. You shouldn't have any doubt in the sum. So the way we solve this sum is, first we just found out what was the work done by the gravitational force. It came to be positive. It has to be positive because force produced by the gravity and the displacement were along the same direction. Therefore, it has to be positive, and obviously I got the answer to be like 10, which was like positive. To get the work done produced by the resistive force of air, first I'll have to fix the sign. To fix the sign, resistive force given by the air and then the displacement were actually opposite to each other, therefore I got the negative sign, right? Next, to get the work done by the air, resistive force of the air, I just need to know what was the force, resistive force given by the air. That is something that I wasn't able to find, because they haven't given any data regarding resistive force given by the air in the question. Okay, what they've given us over there is it reached with some less velocity than the velocity that was expected. So if I know the final energy that the drop possesses compared to that of the ideal energy it has to possess, then if I just do the subtraction between those two things, I'll end up getting the energy that got lost to the surrounding, right? So obviously that will be in positive because I've already fixed the sign over there, right? So you should be clear with this question, okay? So this question is a little bit lengthy and tricky, but the point is it is easy. And by the way, only if you do the first part, you'll end up getting the answer, right? You shouldn't have any doubt in this sum. Let's move on to the next one. Next sum is a particle of mass 10 gram moves along a circle of radius 6.4 centimeter with a constant tangential acceleration, okay? So you're having a mass that's equal to 10 gram. It is moving in a circular motion and they have given us the radius to be like 6.4 centimeter. What they've given extra over here is it has a constant tangential acceleration, which means when it is moving in a circular motion, its velocity, I mean, its magnitude of velocity, which means speed is constantly increasing. That is how it is moving in a circular motion. So that is when you will have like constant tangential acceleration. Okay, you need centripetal acceleration to pull it so that it is moving in a so that it is going to move in a circular path. Okay, so that is needed. But when you have like tangential acceleration, it simply means the speed is also increasing while it is moving in a circular path. Okay, we have seen this one already in the chapter of motion in a plane, right? You shouldn't have any doubt. Okay, so here you are having like constant tangential acceleration they have given us. Then what they have given us is what is the magnitude of this acceleration if the kinetic energy of the particle becomes equal to 8 into 10 power minus 4 joule by the end of second revolution, okay, after the beginning of the motion. Fine. So what they are asking us to find is what is the magnitude of this acceleration. So that's what I need to find. This acceleration they have given us clearly, which means only the tangential acceleration that they are asking. Okay, fine. While solving some, I'll just tell you if they've given you like net acceleration, how to do that one. But as of now, it is pretty clear. They're asking us to find the magnitude of this tangential acceleration alone, right? So this sum will be a kind of like kinematic equation sums, okay? Right. So here, what is the magnitude of tangential acceleration if the kinetic energy is something equal to 8 into 10 power minus 4 joule, and they have given us that too at the end of second revolution, which means it has completed two complete rotation. Fine, two complete circular motion. Got it? So they have given us everything. Let me do the solving over here. Fine. So here to get the final velocity, okay, I'll use the kinetic energy because kinetic energy half mv square will be equal to this answer, which is 8 into 10 power minus 4 joule, right? So I've told you this sum is a kind of kinematic equation sum, right? So here I'll have to get the A tangential. So to get the A tangential, what they've given over here is like velocity and the displacement is known, right? I do not know anything that is related to the time. Therefore, I'll use the third kinematic equation, right? So if I ended up getting the final velocity in terms of v square, okay, initial velocity was like 0, right? It is obvious like at the end after the beginning of the motion, which means it is obvious that the initial velocity has to be 0 because at the beginning of the motion the velocity has to be 0. Only after completing like 2 revolution it ended up getting the kinetic energy. So from that I'll find the final velocity. So the final velocity will be known. Initial velocity will be like 0. Same way here, instead of moving in a linear fashion, it is moving in a circular motion. Therefore, A tangential is nothing but the acceleration over here, which I need to find out. And the final S displacement will be equal to 2 times the circumference of the circle. So it will be like 2 times 2 pi r. Okay, so that will give me the displacement that it has covered, right? So first target for me to find out is actually the v square, right? So to get the v square, half m v square kinetic energy at the end of 2 revolution will be equal to 8 into 10 power minus 4 joule. Okay, if I do solve this one, I'll get the velocity, the final velocity. Okay, so you will have, let me substitute the mass into it, therefore you will have like 2 will get multiplied. So that will be like 16 into 10 power minus 4. Here mass will be equal to 10 power minus 2 kg. Okay, 10 gram. Therefore that will be equal to 10 power minus 2 kg into v square, right? If I solve this one, you'll get the value for v square, right? So let me do the solving. So 10 power minus 2, 10 power minus 4, that will give you like 10 power minus 2. So v square will be equal to 16 into 10 power minus 2 meter per second. Okay, now I have got the v square. Then you have got like v square minus u square, that should be equal to 2as, right? I'll have to substitute it in this equation. The final velocity v square is known. U square will be equal to 0. So this term will go to 0. Then you have got like 2as. So instead of a, I'll substitute like a tangential. So s will be 2 times the circumference of the circle, right? Let me do the solving. You will have, for v square, I'll just plug in 16 into 10 power minus 2. That will be equal to 2 into 8 tangential. That's what I need to find, okay? So 8 tangential into the displacement that it has covered along the periphery of the circle, right? So that will be like 2 times the circumference of the circle, okay? So that will give you like 4 pi r, okay? So instead of pi, let me put in 3.14, okay? 3.14 into r. So for r, you will have like 6.4 centimeter, that is in centimeter, therefore you will have like 6.4 into 10 power minus 2 meter. 6.4 into 10 power minus 2 meter, okay? So if I do the solving, I'll get the A tangential, right? So here 10 power minus 2, 10 power minus 2 will get cancelled out. Then what do we actually have is like 4. That will give you like 4 over here. These two will get cancelled out and you'll have like 2 over there. Got it? Then if I do solve these two parameters, you will have like 3.2 left, right? So you'll have like 3.2. Yeah, that's right. Therefore, A tangential will be equal to, you have got like A tangential, right? So A tangential will be equal to 1 divided by 3.14 into 3.2, right? If I do multiply these two terms, I'll get the A tangential, okay? 1 divided by that term will be like A tangential. Let me do the multiplication, okay? So here let me do an approximation over here, which is like 3.2 itself, okay? So you will have like 3.2 into 3.2 or 3.1, whatever it is. 3.2, you will have 4, 6, okay? And then you'll have like 3 to 6 and then 9, okay? So that will be like 4, 2, 1. That's going to be like 10.24. So the answer here is like 10.24, something closer to 10.1 and 2, okay? So in the denominator, you will have A tangential, which will be equal to 1 divided by 10.2, okay? So this will be the A tangential, 1 divided by 10.2. When I look at the option over here, so they have given it in decimals, 0.18, 0.2, 0.1 and 0.15, okay? So I'll have to divide these two things to get the decimal out of it. But when you look at it, it is pretty clear that 1 divided by 10 will be the closest approximation for the options that they have given over there, okay? So it is like 1 divided by 10, that will give you 0.1, okay? Or else the answer would be like 0.12 or 11. But the next option, when you look at the option, it is clear like that is equal to 0.15, right? So it wouldn't go to 0.15. Somewhere the answer will be fluctuating between 0.1 to 0.11 or 12. The next option is actually pretty deviating from 0.1, okay? Therefore it is clear the answer here is like 0.1 meter per second square, right? So the answer here is option 3. Fine. The sum should be clear. You shouldn't have any doubt. So here, if you look at the question, they have given us the magnitude of this acceleration, which means they are asking us to find the tangential acceleration alone. Okay. If they are asking us to find the net acceleration, what I should do is, so you'll have to do like one more extra step to it. Okay. The process will become lengthy. So here, if they are asking us to find the net acceleration in that situation, so this will be the tangential acceleration that will be along the direction of motion. Same way, centripetal acceleration will be directed towards the center, okay? So these two stuff will be perpendicular to each other. Obviously centripetal will be radially inwards, this will be perpendicular, okay? So the net acceleration will be at certain inclination, okay? So to get this a net, I'll have to take the root of AT square and then the AC square, right? I have already taught you in the theory part of motion in a plane. So that will give you the A net. Okay. So here I have just found out the A tangential and I marked the answer. If they're asking us to get the A net, then I'll have to get A centripetal. So to get the A centripetal, I know the velocity, right? So A centripetal will be equal to V square divided by R. So that will give you the A centripetal. So after getting this A centripetal, I'll have to find the resultant vector. So to get the resultant vector, that will be equal to root of AC square plus AT square. So that will give you the A net. Got it? So in this question, they have just asked as the first step, I mean the first part, okay? They're asking us to do the A net, then the sum will also become lengthy. So you'll have to find one more A centripetal, then I'll have to take the resultant of those two components, A centripetal and then the A tangential, that will give you the A net acceleration, okay? So this sum should be clear, you shouldn't have any doubt. So this sum is a little bit lengthy, okay? And also a little bit tricky. You should get the sum, you shouldn't have any doubt. Let's move on to the next one. Next sum is a particle moves from a point minus 2 I cap plus 5 j cap, okay? So a particle is moving from one point, they have given us the position to a new position which is like 4 j cap plus 3 k cap. When a force of 4 I cap plus 3 j cap Newton is applied, how much work has been done by the force? So here I'll have to get the work done by that particular force, okay? So they have given us the work done also. So they have given us the position, initial and then the final position. Therefore, if I do subtract those two vectors, I'll end up getting the displacement d. Okay. So if I get the displacement d, then obviously vector f dot vector d will give you the final answer. Okay. So that's going to be the work done. Got it? So here in the situation, work done will be equal to vector f dot vector d. Okay. So they haven't given us the displacement straight away, which means final position minus the initial position. In turn, they have given us the final and then the initial position. Just do the subtraction, vector subtraction of these two vectors, you'll end up getting the displacement vector. Okay, so once you know that displacement vector, vector d, then obviously if I do the dot product, I'll get the answer, right? Simple sum straight away. So here you will have like displacement d will be equal to final position minus the initial position. Therefore, that will be equal to 4 j cap plus 3 k cap minus of negative 2 I cap plus 5 j cap, right? You should be clear with this understanding, right? They have given us just the position, where it has started, where it has ended, okay? They didn't give you anything that is related to the displacement, right? Now I just need to get the displacement from it. Then I'll do the multiplication. I'll do the dot product with the force. I'll end up getting the work done, right? This idea should be clear. Therefore, you will have 4 j cap plus 3 k cap, right? So here you have got like minus 5 j cap. So 4, that's going to be like minus j cap. And then you have got like plus 2 I cap over there. So that will be like plus 2 I cap. And then you have got 3 k cap, right? So that will be the displacement d that is needed, right? It should be clear. Then work done will be equal to vector f dot vector d. Vector f will be equal to 4 I cap plus 3 j cap dot product with 2 I cap minus j cap plus 3 k cap. Okay. Now I'll get the answer, which will be like 4 times 2, that will be like 8. I'll have to multiply only the same component, and then 3 minus 1 will give you like negative 3 minus 3 plus 0. You do not have any k component into it, therefore the final answer is like 5 joules. Okay, so the answer here is 5 joule, which is like option 3, right? You should be clear with this sum. So this sum, in the sum, only tricky part is they haven't given us the displacement. Instead, they have given us the final position of those two, final position, okay, for that particular particle. Okay, if I know the final positions of those of that particle, then how will I be able to get that distance between them? Obviously, I'll have to do the subtraction. When I do the subtraction, I'll end up getting that interval between those two positions. Okay, so that will be the displacement, right? It should be clear. Simple sum, you shouldn't have any doubt in the sum. Let's move to the next one. This sum is also same as that of the previous sum. Let's see what the sum is. A uniform force of 3 I cap plus j cap Newton acts on a particle of mass 2 kg. Okay, so they have given us the force and they have given us the mass of that particle. Hence, the particle is displaced from position 2 I cap plus k cap. So they have given us the position here, and the final position was equal to some another vector, okay, meters. The work done by the force on the particle is, I need to find the work done, right? So work done, W will be equal to vector F dot vector D. Okay, so I will have to get the displacement. So to get the displacement, I just have to subtract final position minus the initial position. That will give me the displacement D. And let us do the dot product, we'll get the answer, right? Same as that of the previous sum. Only thing that they've changed over here is just the numbers, right? You can do this one as a homework also. You just pause the video and do it by yourself and find out the answer, right? Okay, so displacement D will be equal to final minus the initial, so that will be 4 I cap plus 3 j cap minus k cap negative of the initial vector, that will be like 2 I cap plus k cap. Okay, if I do the subtraction, you will have 4 minus 2, that's going to be 2 I cap, and then you'll have like plus 3 j cap, and then you'll have like minus k cap minus k cap, that will be like minus 2 k cap. Okay, so now I have got the vector D, right? Now I'm ready to just multiply it with the force. Fine. So in the next step, I'll find out the work done, which will be like 3 I cap force was equal to 3 I cap plus j cap, right? You do not want to worry about the mass that they've given. That's the extra piece of information that they've given, which is not needed for this sum. So that will be 3 I cap plus j cap dot product with 2 dot product with 2 I cap plus 3 j cap minus 2 k cap. Okay, so now I have got two different vectors, and just do the dot product of these two stuff, you'll get the dot product answer. Okay, so that's like 3 2, that's going to be like 6 j, that will be like 6 plus 3, and then the other one will be 0, right? So here work done was equal to work done was equal to 9 joule. So that should be my answer, which will be equal to option 3. Okay, so the answer here is 9 joule, which is like option 3, right? You should be clear with the sum. You shouldn't have any doubt in the sum. Let's move on to the next one. Okay, next sum is a particle of mass 5m at rest suddenly breaks on its own into 3 fragments. Okay, so for this sum I'll do the momentum conservation. Okay, so whenever you have like breaking explosion, then in that situation you should get that perception of using momentum conservation. Okay, two fragments of mass m each moves along mutually perpendicular direction with the speed v each. Okay, so we have done these kind of sums in the laws of motion chapter itself. So up to this, entire concepts will be from the laws of motion chapter itself. What they're asking us to find is the energy released during this processes. Okay, so I'll have to sum all those kinetic energy possessed by those three masses. Okay, for the case of two mass, I just know it just splits into I know the mass and I know its velocity. So only leftover part is the third piece, which is like 3m, and I'll have to know the velocity of that particular mass. Okay, so to get that velocity of that particular mass, I'll have to use the momentum conservation, obviously, right? So let me use the momentum conservation, which is like initial momentum that will be equal to the final momentum, right? Got it? So the initial momentum will be equal to the final momentum. Initial momentum is obviously 0 because it was at rest and suddenly it broke into 3 fragments. Okay, which means it's a kind of explosion case, therefore the initial momentum will be 0. Okay, initial momentum was equal to 0. Two fragments of mass m moves along mutually perpendicular direction. Okay, so here you have got a mass that's going to split mutually into 3 pieces, right? Fine, so one is like along the plus x axis and the other one will be along the plus y axis. Okay, whatever it is, you can just randomly choose the direction. I have already done these kind of sum in the last chapter itself, therefore you should be clear with this idea. Okay, then what will be the velocity of the third part? That's what I need to find, right? So 0 will be equal to the final momentum. So in the case of the final momentum, that will be equal to 1 mass and its direction is like vi cap. Okay, it splits such that each mass, these two masses have the mass equal to m. Total mass was equal to 5m. Okay, so for the first two pieces, it will be like mv I cap, and then you'll have like mv j cap, and the third piece will be like 5m minus 2m, that's going to be 3m. Okay, and the velocity v dash, that's something that I need to find. Okay, so to get the v dash will be equal to negative of mv, so mv dash will be equal to negative of mv I cap minus 3mv dash, right, will be equal to negative of mv j cap. Okay, so here m will get cancelled out, m will get cancelled out, therefore v dash will be equal to you'll have that component into it, right? So the v dash will be equal to v by 3 I cap negative v by 3 I cap negative v by 3 j cap. Okay, so now I have got the v dash from it. So the next one is to find the magnitude of this vector, velocity vector. So v dash, so this is a kind of vector, right? So if I have to get the magnitude for it, that will be equal to root of v by 3 the whole square plus v by 3 the whole square, right? So that will be the velocity vector that is needed over here. Okay, so that should be equal to, let me do the solving. So you will have root of 2 v square v by 3 the whole square, right? So 2 v by 3 the whole square, right? So if I do take the root for it, you will have v dash, you will have the v dash which will be equal to root 2 v divided by 3. So that will be the final v dash that is needed. I mean the v dash of the third mass that is needed. Okay, now I just have found the unknown v that is needed to get the energy released during this process. Fine. So to find the total energy that got released, I'll just have to do the solving, you'll get the answer. So easy sum. Okay, so the total energy released will be in the form of kinetic, therefore k will be equal to half m v square for the first one, and then for the next mass you'll have like one more half m v square, and then for the third mass which will be like half, that will be 3m. Okay, for v dash square I'll substitute like 2. Okay, let me do the square straight away. 2v square divided by 9. Got it? Yeah. Okay, you shouldn't have any doubt. Let me factor out half mv square and do the solving, I'll get the answer. Okay, if I just factor out like half mv square, you'll have 1 plus 1, that will give you like 2 plus even in this case, like I'll just factor out half mv square, right? So the leftover term will be like 3, 2 and then 9. Okay, let me do the cancelling over here. So 3 and then that will give you like 2 by 3, right? So the only term that will be left will be like 2 divided by 3. Therefore inside the bracket you'll have like 2 by 3. Okay, so if I do the cross multiplication, you'll have like half mv square, and then like it will be 6 plus 2, that will be like 8, right? No, yeah, 6 plus 2 will be like 8, so that will be 8 divided by 3. Okay, just do the solving, you'll get the answer. Half and then the 8, these two things will get solved and you'll have like 4. So the final answer will be like 4 by 3 mv square. So the answer here is 4 by 3 mv square, which is like option 4. 4 by 3 mv square will be the answer for this question. Okay, so this question is an easy one. Okay, we have seen this type of question multiple times in the previous chapter. So in this chapter we have just done an extra step to it, which is like finding the final kinetic energy. Okay, it should be clear, you shouldn't have any doubt. Let's move to the next one. This sum is same as that of the previous sum. Okay, so only thing that I've changed over here is just the magnitude. Okay, so just pause the video over here and do it by yourself and then verify it whether you're getting the answer right or not. Okay, same steps and everything will be the same, only the numbers is just they have changed. Okay, so here they have given a body of mass 4m is lying in an xy plane at rest. So initially it is at rest, it suddenly explodes into 3 pieces. 2 pieces each of mass m moves perpendicular to each other. Okay, obviously with equal speeds v. the total kinetic energy generated during the explosion. So they're asking us to find the total kinetic energy, right? So I'll have to get the velocity of the third piece using the momentum conservation, right? So the initial momentum will be equal to the final momentum. From that understanding, I'll do the solving. So the initial momentum was equal to 0. The final momentum was like mv I cap for one component, and then you'll have like mv j cap for the second piece, and the third piece will be like 2m because the total mass was equal to 4m. 2m v dash. I'll have to find the velocity of this third mass, right? Here m will get cancelled out. Therefore, 2v dash will be equal to negative v I cap negative v j cap, right? So I'll have to get the magnitude for this particular one. Therefore, v dash will be equal to, I need to get the magnitude, right? Therefore, it will be equal to root of negative v by 2. Okay, so negative v by 2 the whole square plus negative v by 2 the whole square, right? So you'll get the v dash to be, v dash will be equal to, yeah, you'll have like root 2 v divided by 2. Yeah, yes, right? So that's how it should be. That will be equal to v divided by root 2. Got it? Now I have got the magnitude of the third piece velocity. Okay, now I'll have to get the total energy. So the total energy will be the energy produced during the during the explosion will be kinetic. Therefore that will be like half mv square, and then half mv square for the second piece. Finally you will have like half, the third piece had a mass of 2m and the velocity was equal to v divided by root 2. If I just square it, you'll have like v square divided by 2. Okay, it should be clear. Now if I do the solving, I'll get the answer. So I'm just going to factor out half mv square from it. If I factor it out, you'll have like 2 plus, yeah. So those two will get cancelled out, right? So here 2 and 2 will get cancelled out, and then you'll have like half m v square, that 2 will get factored out, and then you'll have like 2 plus 1. Yeah, so this will give you 3 by 2 m v square. So that's my answer. 3 by 2 mv square will be my answer, which is like option 2. Fine. You should also have got this answer, which is like 3 by 2 mv square, right? So this is same as that of the previous sum. You shouldn't have any doubt. Let's move on to the next one. So this will be the final sum for this particular session. Okay. So this sum is actually conceptual based sum. Let us do it. You have got an engine pumps water continuously through a hose. Okay. So you have an engine that is pumping water continuously through the hose. Water leaves the hose with a velocity v, and m is the mass per unit length of the water jet. Okay. So the water is leaving the hose with the velocity v, and the mass that it is getting ejected out will be, and the mass is equal to m. Okay, so that is mass per unit length. That's what they're given over here. Okay, so the mass, the weight of the mass per unit length will be equal to m. Fine, so I'll explain you in a minute. You have got like what is the rate at which kinetic energy is imparted to a water. So what they're asking us to find is rate at which the kinetic energy. Okay, so they're asking us to find the rate of energy. Got it? So whenever they give you the term rate, it actually means I'll have to divide it by that given time, right? So when I divide the energy by time, I'll end up getting the power. So what they're asking us to find is actually the power of that particular engine pump. Okay, so that's what I need to find. So here they're asking us to find the rate at which the kinetic energy is given to the water. So the rate at which kinetic energy given to the water is nothing but the energy of that particular water pump. That's power of that particular water pump. Okay, that's what I need to find over here. Okay, so here I just need to find the power of this water pump. Okay, so to get the power of the water pump, let me draw the diagram of the hose. So you are having an hose, okay, and then water is getting ejected out. Water is leaving this hose with an velocity v. So the velocity with which the water is getting ejected out is like v. Okay, that's going to be the v. Fine. So obviously you will have certain mass that's going to come out of that hose, which will be the water mass that will come out. Okay, so the mass of that water will be equal to small m. Okay, so whatever length it has covered, Fine. So let us put it this way. If the water that came out had a length of like 2 meters and the mass of that water was equal to 2 kg, then mass per unit length will be like mass that got ejected out divided by its length. Okay, so that will give you the mass per unit length, right? So it is pretty obvious, right? So they're given us mass per unit length. So one unit length of that water jet has to give a mass that is equal to small m. Okay, so to get this small m, what I need to find out over here is, if capital M mass was ejected and the length was equal to such and such, then capital M divided by L will give you that small mass that is required. Okay, so here the total mass that got ejected from that hose was equal to capital M. Okay, so that came out from that hose was equal to capital M and the length was equal to capital L. Fine. If that was the case, then mass per unit length will be equal to capital M by L. So the mass per unit length will be equal to capital M by L. So it should be clear, this much amount of mass got ejected and the length that it has produced was equal to capital L, which will give you the mass per unit length. So the division of those two things will give you the mass per unit length. Fine. So now I have just signified this small m. Got it? What they're asking us to find is actually the power of that particular pump, or else the rate at which kinetic energy is imparted to the water. Okay, so to get the rate at which kinetic energy is imparted to the water, I'll have to divide that energy, kinetic energy, divided by that given time. Okay, so the kinetic energy over here is like half mv square, right? So it has ejected capital M mass of water and in that given time. Okay, so it should be like, so I'll have to get the power, right? So power is nothing but the energy divided by that time. So to get that power, total mass that got ejected was equal to half m, okay, which is like capital M. So that was the mass that got ejected, right? So that is like half m v square, right, divided by the time t. So that was the total time t, right? Here I'll have to replace this capital M in terms of small m, right? Because in the option it is pretty clear, everything was given in terms of small m. So that should be clear because mass per unit length is given over there. So if I'll have to do the rearrangement. So capital M will be equal to small m times L, right? If I do the next step, you will have like half m times L v square divided by t. Okay, now let us just look L divided by T. So this is the only term that I'm going to consider. So if I just consider that one, L divided by T, what was the total length that it was able to produce divided by the time T? Okay, so what was the total length that particular water has covered in the given time? Okay, so length by time will give you the velocity with which that particular water droplet or molecule is traveling, right? So if this water molecule that is getting ejected out has traveled a distance, some distance L, divided by that time will give you the velocity with which the water is getting pumped out. Okay, so that will give you the velocity, right? So here the power will be equal to, I have got the answer. Therefore, power will be equal to half m. So this term is nothing but the velocity. Again, the velocity with which the water is moving. Okay. Therefore, you will have like velocity, one more velocity term into it, which will give you like half m VQ, right? So the power of that engine or the kinetic energy that has been given to the water jet will be equal to half m v square, where here the mass is nothing but the mass per unit length. Okay, it's not the total mass that got ejected. Okay, it's just the mass that got ejected per unit length. For particular 1 meter, what was the mass that came out of that water jet? That's what I'm going to find over here, right? So that mass will depend on the diameter. I mean, it will depend on that cross-sectional area of that hose. Okay, if the hose was bigger, then in that situation more amount of mass would have been ejected. If it was small, then depending on that, depending on that cross-sectional area of the hose, mass will vary accordingly. Okay, and also it also depends on the velocity with which the water jet is coming out of that particular hose. Okay, water is coming out of that particular hose. Fine. Therefore here the answer will be equal to half m v cube, which v cube, which is like option 4, right? You should be clear with this sum, right? You shouldn't have any doubt in the sum. So this is like a simple sum, a conceptual based sum. Okay, so in this sum, what they've given is the mass per unit length, right? They haven't given you the total mass that got ejected in the given time. Instead, they've given us the mass per unit length. Okay. To get the power, what I have to find is what was the total mass that got ejected, which is like half mv square divided by the time. So to match that total mass with the mass per unit length, I just rearranged it accordingly, and then I ended up getting the half mv cube, where m is the small m, which is mass per unit length. Okay, you should be clear with this question, right? So in this session, altogether, we have seen like 11 sums. Those sums were mainly related to vectors, dot product. Okay. And then we did see sums based on the kinetic energy and momentum conservation, right? You should be clear with all the sums that we have seen. You shouldn't have any doubt in it, right? So with this, the video gets completed. Bye.